It's another math day here with teacher Jenny. Join me for another topic, and the topic is hypothesis testing with known variance. So when you do hypothesis testing, you will be following different steps. More likely, you have different number of steps based on your teacher as well. So if your teacher is presenting it with 4 steps, then you have to follow that one. If your teacher is presenting it with 5, 6, or 7, then you need to follow that one. But anyways, they have the same process still, but only that they're adding more steps to it so that it will be easier, a lot easier for their students. So for me, I am introducing here 5 steps. So let us try to find out what are those 5 steps. So here we go. So let's start with our first problem. Okay, here is our first problem. A recent survey claims that students spend an average of 4 hours a day playing Mobile Legends with a standard deviation of 30 minutes. A random sample of 9 students is taken from a normally distributed population of students who spend an average of 3.5 hours playing Mobile Legends. Using the 1% level of significance in there, is the statement given by the survey correct? So we need to test out whether the statement given out on that survey is correct or not. So how do we do that one? We need to test the hypothesis in there. So in testing hypothesis, we have to follow the different steps. So the first one here is for us to state the hypothesis. So if you don't know how to state the hypothesis or how to write the hypothesis, you may refer to my video on how to write hypothesis. It is found on the description below. So kindly click on that one and watch that before you proceed with hypothesis testing. So let's try to state our hypothesis here. So when you state your hypothesis, you always have to look for your parameter. So parameter usually is attached to your population because when you say parameter, that is a measure in which it describes your population. Now, when you say measure, that is normally the average, and then you have their mean, median, and then you have also standard deviation. That is also a measure. But this time, we are trying to test out the average time in which a student spends a day playing Mobile Legends. So, this is now the parameter because we have our population as the student, and the one that describes that one, or the measure that describes the population there, which is the student, is the average of 4 hours a day playing Mobile Legends. So that's the parameter in there. So that would simply mean that when you try to state your hypothesis here, we always have to use that one. And we start with our null hypothesis. This is our symbol. So we always start with our symbol for the name of or the type of the hypothesis there. So we start with null hypothesis, and then you have to do the colon, and then you write your symbol form for that parameter. So we have the population mean with the symbol mu in there, and that will be equal to 4 hours because it says there, it is said in there that you will have their students spend an average of 4 hours. So that means to say that your population mean is equal to 4. Next, we go for writing our alternative. So this is now the symbol for the alternative hypothesis. So we have H sub A, and then we put again the colon in there. And then of course, we are still using the same parameter, only that we are changing now this symbol. So from the equal to there, it's gonna be not equal to 4. Now, why are we using not equal to 4? Because when you say alternative hypothesis, you may have there greater than or less than. Because if you try to look at this one, you have there, you wanted to know whether the statement given there by the survey is correct. So that means to say, we will be testing out whether it's correct, it is equal to 4, or it is not equal to 4. And by that one, we can say that that is incorrect when that is not equal to 4. So that is why we're using not equal to 4. Now, next, after stating the hypothesis, we move to our second step. Second step is determine the appropriate test to be used. So, this is now what we are going to make use in order for us to know what to choose between z-test and t-test, because when you try to check whether they have significant difference or not, you will be most probably using z-test or t-test. So to know which of those two tests statistic will be using, we will be using this diagram. So let's start and know how to use our diagram. So first off, we need to know what is the sample size. If you try to look at the problem, we have a sample size here which is equal to 9. So that's our sample size. Now you will be answering whether is 9 greater than 30. That is no. So you will be following this diagram, leading you to the next one, which is answering whether population variance is given. Now, if the population variance is not given, but the standard deviation is there, then that means the same thing. So let me just add here standard deviation of your population. If that is known or given, then you will be using z-test. If that is unknown, then you will be using t-test. Now, is the population variance or population standard deviation known or given on the problem? The answer is yes, because we have here a standard deviation of 30 minutes that's coming from our population, which is our students. Okay, so that means we will be using our z-test for this hypothesis testing. So that is how we determine the appropriate test to be used. Now, after determining that this should be z-test, the next thing to do is to follow our step 3. So we have here determining the critical value. Now, in determining the critical value for the z-test, we have here our table for the list of the possible critical value with the given level of significance or the alpha. Now, according to the given there, we are to use the 1% level of significance. So that would simply mean that we will be expecting that our tail part area of your normal curve, because this is normal curve because we're using z, so that will be normal curve. And the tail part of your normal curve will have an area which is equivalent to 1%. I hope that's clear. Now, in order for you to locate the z value for that area, you will be referring to this table. So how to locate the z value in here? You start off with the level of significance, that's 1%. So you locate the level of significance here. We've got 1%, 2.5%, 5%, and 10%. This is the most commonly used level of significance in the world of research. But if in the event that your level of significance there is not found on the table, then you may have to locate that on your own by simply locating on the z table the area which is equivalent to that level of significance. So I hope that's clear, everyone. Now next, we have here the level of significance, which is 1% based on the problem. Next thing for you to do is to know what type of test are we having. Now, when you say what type of test, that will be very much dependent on your alternative hypothesis that you have declared on the starting point, like on the step one. Take note, your hypothesis here are the following. We've got the null hypothesis, which is with the population mean equal to 4. And we have our alternative, which is the population mean is not equal to 4. Now, how to determine the type of test, whether it's one-tailed test or two-tailed test? We just have to look at our alternative. Now, you might be asking whether it's going to be all about alternative on the determining of the type of test. Yes, indeed. You have to look at the alternative hypothesis in determining the type of test for that given problem. Now, how would we know whether it's one-tailed test or two-tailed test? First, you have to take note that there are symbols for the one-tailed test and the two-tailed test for that alternative hypothesis. When you say two-tailed test, the symbol here used will be not equal to. That should be present on the alternative. For the one-tailed test, this should be with greater than or the less than symbol on the alternative hypothesis, so that you will have it as one-tailed test. Now, if you try to look at the problem there, or our statement for that hypothesis, we have your alternative with the not equal to symbol. So that means to say the type of test here is two-tailed test. So that is what we are going to look at, what z value is gonna be the intersection for the type of test and the level of significance. And that is this one. Now, by the way, that C there stands for the critical value. But in my class, I always have to make sure that we have the same symbol for my class. I always have to state that one as, for the critical value alone, as Z sub C, that will be equal to positive, negative 2.575. So that will be my critical value. Now, I'm using the Z here because we've known out from step number 2 that our test is gonna be Z test. So that will be Z sub C, that stands for the critical value on your Z, or which is Z, that will be equal to positive, negative 2.575. Positive, negative, because you're having a two-tailed test. One from the left side, one from the right side. The negative 2.575 will be on the left side. The positive 2.575 will be at the right side. Now, let's try to look at that one on our normal distribution curve. So, you just have to imagine that the curve there and the horizontal axis is not touching, because that's one property of your normal distribution. So anyways, we try to locate those Z sub C values. We have the positive, negative 2.575. We locate that one on your curve. So negative 2.575, that will be somewhere on the left side. So it's gonna be more likely somewhere here. That will be our negative 2.575. That's one value for your Z. Next, we go for the right side. That's positive 2.575. So more likely that's somewhere here. So this is now our 2.575. Now, what are we going to do? Same thing, we are going to connect a line here towards your curve. And then, we will be shading this tail part area. Okay. Now, this tail part area that I'm shading We call this one as our rejection region. Meaning to say, this is now our basis that we will be rejecting our null hypothesis if the next z value that we're computing, because later on we'll be computing for the z value, if that will be lying in that shaded area, automatic will be rejecting that one. Okay, so I hope it's clear. Now, also, since this is two-tailed test, we also take this one as another rejection region because we have two-tailed test. So that means to say we have two rejection region, one from the left side, one from the right side. So again, once you get the z value later on, once we've computed the z value, and we happen to know that the z value there is located on the shaded region, automatic we are to reject our null hypothesis. So this is now our condition that if our z sub t, we're naming it because again, you might be confused because we have two z value here to consider. So we will be naming the next value as z sub t because we are going to compute our test statistic here. So we call that one as z sub t. Sorry for the discrepancies on my letter Z. That is what I usually write. Sometimes with a slash in there and sometimes not. So sorry on that one. Anyways, moving on. So if your Z sub t there is greater than or equal to your 2.575, or there is an or here because we have two z values to consider. This one here would simply mean that if you've got there a z sub t value which is greater than 2.575, that means to say it is located on our rejection region. That means to say we have to reject a null hypothesis. Next, we have another condition. You can have there or, it's going to be or, because later on, we will be computing for the z value. And once we have a positive or a negative value, we will be comparing that back there for the critical value. So, if that z value is greater than or equal to 2.575, we reject the null hypothesis. Or if your z value later on, which is computed, will be not greater than, sorry, on that one, that should be less than because your left side here, the values on the left side of this negative 2.575 are less than that value, automatic we also have to set it as less than or equal to negative 2.575. Then we can have our decision that we are going to reject our null hypothesis. So this is now the condition. So we will be going back to this one later on as this is our guide in decision making. So we will be deciding whether to reject or to accept our null hypothesis. Let's now continue to the next step. So we are now on our step 4. So step 4, we compute for the test statistic. Now take note, our test statistic that we have for this problem is the z-test. So we are going to make use of our formula here for the z sub t, which is equal to x bar minus your mean, which is the population mean, over the standard deviation, which is the population standard deviation, divided by the square root of your n. So that is how we are going to compute for our test statistic. Next, All we have to do is to know the different information that we need there. First off, we need to know the given for our x bar. X bar is our sample mean. So based on the problem here, we can just locate the sample mean where we have the statement on the sample. So we have it here. A random sample of 9 students is taken from a normally distributed population of students who spend an average of 3.5 hours. So that means to say that our x bar is 3.5 hours. Next, we have our population mean. Population mean is the one that we have from the population. So this one is our population mean. So normally, when we have the population mean, that is what we are using on the hypothesis. Okay? So population mean is 4. And the next one is we have our population standard deviation. So based on the problem, we have the population standard deviation, which is 30 minutes. So we have 30 for that one. And then we have to take note as well that we are using hours in there. So we cannot make use of the 30 minutes. We have to convert that one into hours. So how many hours are there in 30 minutes? That means to say it's only 0.5. So our population standard deviation here is 0.5 hour. Okay? Because 30 minutes is just half of the hour. So I hope it's clear. Next, so that means to say we'll be using this one. Let me just box it so that you will not be confused over what to use. So here, or let me just erase that one so that it will be a lot easier for you. So let me erase. Okay. So from 30, we have here 0.5 because that is half of the hour. Next, we go for our n. We need the information for the sample size. So according to this one, we have a sample of 9. So our sample size is 9. So all we have to do is to just plug in everything and we are good after that one. So plugging in, we have our z sub t, which is equal to x bar, that's going to be 3.5. And then we subtract that by 4. And then we are going to divide that with our population standard deviation, which is 0.5. And then we're going to be dividing that with the square root of your 9. So plugging that in your calculator. So our z sub t here will be equal to -3. So that is our value for that test statistic. So what are we going to do next? Now, since we have the computed test statistics, so we are now going to make our decision and we need to go through step 5. Step 5 is decision making. Now, take note, everybody, there are 2 possible decisions that you can make. You can make a decision which is going to be rejecting the null hypothesis, or you have to fail to reject HO. So this is the only decision that you can make. So you just have to choose between the 2. But it's not going to be a free choosing because you will have to base that one with the test statistic and the condition a while ago. Now, take note of the condition there because you've got there your z sub t and your z sub c. So take note, we have z sub t here, which is equal to -3. And a while ago, we've got 2 values for the z sub c, or the critical value, which is positive, negative 2.575. And that is somewhere here. Let me just plot it in so that we can have a clear picture on that one and what we are going to decide on that one. So we have negative 2.575. So this is now the area on the tail part. And by the way, when you add those areas, that will be equal to your level of significance, which is 1%. So anyways, moving on. Now, take note, we have our critical value or critical region here, which is going to be this part on the left side and this part on the right side. So that means to say, if our Z sub t falls on that region, either of that region, automatic we're going to be rejecting our null hypothesis. So let's try to trace, or let's try to locate negative 3. So negative 3, that's negative that is found on the left side. And negative 3 is this one here. It is located on the rejection region. So that means to say, we are now sure that what we are going to do or to choose for a decision is for us to reject the null hypothesis. So that would simply mean that we can make our conclusion here that since we rejected our null hypothesis, we can conclude that based on the sample selected there, the statement given by the survey on the mean number of students, or the average, not the mean number of students, but the average time spent for a student on playing Mobile Legend is 4 hours, is incorrect. So that is how we are going to do our hypothesis testing. Okay? So again, this is really needed on decision making, or step number 5. We have to do a conclusion. So we can say there, since we have to compare, we have our Z sub C and Z sub T. Once we compare that one, we have our negative 3 is less than negative 2.575. Now, take note, I'm using only one of the value there on the critical region because that is where we reject our null hypothesis. I'm not using the positive 2.575 because we're not dealing or touching that rejection region there. Okay? So we can have there, since negative 3 is less than negative 2.575, then reject HO. So that is our decision. And based on that decision, we can just have to write a conclusion from there. So we can say, hold on, sorry on that one. I'm thinking, I went black out there. Sorry. Okay, so we have there, therefore, your claim, or therefore, the survey which claims that the students so this is a lot of writing, spend an average of 4 hours a day in playing. Let me have ML to shorten it up, is incorrect. Or you may rephrase that one. That is really okay. So that is how you do hypothesis testing with your known variance or standard deviation on your population. So again, I hope you were learning something from me. This is your teacher, Jenny, saying, have a nice day.